Hello guys and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today we're in the realm of statics, still solving these problems with the cables and the counter forces to keep everything in place. Nothing special about this problem except the fact that now the force is not pointing downwards completely. So we're going to have two reactive forces on the tension, and that's going to change the disposition of these forces a little bit. Moreover, I will go ahead and tackle one of the main questions that I get from students when solving these problems, which is how the hell do I know how to build my triangle, my force triangle? And it's actually much simpler than you guys think. There's really no way of going wrong, and I'll prove this to you when solving this problem. Okay, so problem statement reads, two cables are tied together at C and are loaded as shown. Knowing that P equals 500 newtons and that alpha is 60 degrees, determine the tension in cable AC and in cable BC. So what we have here is the tension, the force P this way here, and countering that force, right? Stopping, making sure that the sum of forces is zero is a tension AC over here, and also a tension BC over here. Note, very importantly, that here we have a slight change in the forces games being played, because before when we had P going downwards and we had AC and BC stopping it, really AC and BC were countering each other on the X direction, and both were countering P on the Y direction. Here, however, we have different set of rules, right? Why? Because yes, indeed, both BCY and ACY are countering PY, but we have ACX and PX, and what's countering both of these is BCX. So now we're not sure whether BC will be the biggest force acting here or P will be the biggest force acting here. So we're not sure which one is the greatest because of this situation that arises from the balance of forces. Okay, so we're going to need to be to finish up the calculations to be able to know this. Now, how do we solve this? As we always do, we're going to go ahead and I'm going to go ahead and copy this down here. I'm going to make an actual copy of it. I'm going to note the angles that we have. So we have over here we have 45 degrees. Over here we have 25 degrees. And over here we have 60 degrees. Okay, and the way that we solve this is we create the force triangle. And here is where a lot of students, I'm not sure if struggle with the right word, but they get confused because they tell me the following. Well, I can construct two different triangles here, right? Maybe even more. I can construct one like that. Construct one triangle like this, and that's going to give me one force triangle. Or I could go ahead and construct one like this. That's going to give me a different force triangle. And how do I know which one is the correct one when I'm solving this? And the answer is, doesn't matter. They are exactly the same. And we're going to do both ways to prove this to you. Okay, so we're going to do both of these triangles here and solve it for both. So let's start with, let me go ahead and start with this one here first. Go ahead and copy this and place it over here. And if I want to do this, I'm going to go and do, so I'm going to have P over here, then I'm going to have AC over here, and then BC here. Okay, so this is my AC, this is my BC, and this is my P over here. What do we know about these? Well, we know that this guy here, over here, this is 60. So therefore, this is also the 60. We know that the AC makes a, what's the angle of AC? 45 degree angle with horizontal. And we know that BC, this guy here, makes 25 degrees with the horizontal. So right here, we get 25 degrees. Okay, so now all we need to do is just find all the angles for this triangle. We'll note that this one's probably the easiest one to find because this is 180 here. So therefore, that red one is just going to be 180 minus 60 minus 45. That's going to give us 110. Is that right? So, no, that's not right. 120 minus 45. 75. So that's going to give us 75 right there. Then what next? We can go ahead and what I can do is I can continue this guy here all the way up. I can create like a separate triangle here. This separate triangle also has to have the same angle because I'm going all the way to the horizontal, so this has to be the 25, just like below. And I know this other one is 45, so that means that this green one here will be 180, sum of all the internal angles, minus 45, minus 25. And that's 60, 70, so that's 110. If that's 110, and we know that this guy here, the total sum of this is 180, right? Because it's a flat line, that means that this blue one here has to be 180 minus 110, which is 70 degrees. And then last but not least, we have, let's get different color here. Let's get purple. This purple here has to be the internal of the triangle, 180 minus the 70. Now we already found, minus the 75 that we already found, which gives us 35. So I'm going to go ahead and copy this triangle with the forces like so to have it nice and neat here. Oh no, I'm missing AC. Oh, AC. Okay, so we don't need this anymore. We don't need this, nor this. Okay, so this simple triangle we found out is 70 degrees, 75 degrees, and 35 degrees. Yep, that's the triangle. All right, cool. So now let's go ahead and do the other one. This is the second one here. Okay, so if we're doing the second one, I'm going to do exactly the same approach. No changes whatsoever. So I'm going to go ahead and start by just drawing it better. So I'm going to go from here all the way, no, I'm doing purple now, I guess. Here all the way here. Then we have P, and P is going to go like so. And then we're going to have AC. Not perfectly right, straight lines, but not enough to get in the way. And then P over here. Okay, cool. What do we know about this guy? We know P makes a 60-degree angle with the horizontal, so we know that this angle here is 60. And we're going to go ahead and change colors, or else it's going to be hard. We know that BC makes a 25 degrees. Let's change color here. Makes 25 degrees with the horizontal, so this is 25 degrees here. What else do we know? We know, I can once again expand on my triangle. That'd be kind of a big expansion here. But I also have the AC one. And AC makes a 45-degree angle, right? So there's 45 here with the horizontal. So if I expand this all the way here, I can create this black triangle here. And this guy has to be 45 too. And if that's 45 and this is 25, then this red one here will just be 180. Sum of all the angles of that black triangle minus 45 minus 25. And if that's true, then that's 110 degrees. Oops, not Celsius, degrees. Which means that this blue one here will just be 180. Because it's a flat line, minus 110, which is 70. So this right here is 70. Okay, this one is super simple, right? So this one here is super simple because that's just 60 minus the 25. So that's 35 right here. And then obviously this one here will just be the sum of all of them minus the 70 minus the 35, which is 75 degrees. So what does that leave us? Well, it leaves us with the following. Let me go ahead and grab it. Oh, this. Leaves us with a triangle of 35, 75, and 70. And if you recall, where's our nice triangle here? Let's see the other one we created. Though I didn't draw them exactly, they are the same. They have one side of, actually let's do this. They have one side of P with the opposite angle being 70. So one side of P, opposite angle being 70. That's the same. Then they have one side of BC with the opposite angle being 75. Side of BC, opposite angle of 75. That's the same too. And then finally, just to change colors, they have one side of AC, opposite angle of 35. One side of AC, opposite angle of 35. So, though my drawings are not great, and therefore they don't look the same, they are indeed the same. So you don't have to worry when creating the force triangle, which triangle to make. Whatever you choose, as long as you make a triangle of the forces, you'll be on the right track. Okay, but now, enough of proving that triangles are the same, and let's solve this. We're going to apply the law of sines, which says that the sine of 70 over P needs to be equal to the sine of 75 over BC, which needs to be equal to the sine of 35 over AC. And with that, we can go ahead and just have two equations, two unknowns. So this is going to be super straightforward, right? My AB will be the sine of 75 over the sine of 70 times my P, which is 500 newtons. And my AC will be the sine of 35 divided by sine of 70 times P, which is 500 newtons. Okay, and what I get here for my AB is 513.958, and it keeps going, so I'm going to go ahead and approximate this to 514, excuse me. And that will be my answer right there. And on the bottom here, I get 305.193, and it keeps going. So I'm going to go ahead and approximate that to 305 newtons. And that's going to be that. Okay, so we've solved this completely. But not only that, we also proved that regardless of the way you arrange your triangle, you're going to be able to solve this, so you don't have to worry about it. You should also note that the way that I've solved for the angles internally was slightly different, right, from the two versions that I created, so maybe one is easier for you. So if you're stuck on one, you can just flip it around and do it again. The other thing to note, and this is super interesting, is that AB is greater than P, right? So back to the beginning, back to the original problem when we were discussing this, we were talking about the forces, and we found that this guy here, this tension here, is the biggest tension, followed by this one here, followed by this one here, followed by this one here. So if we're going to do this triangle properly, we should have a very long side for AB, or BC, then a almost the same size but slightly smaller one for P, and then a small one, kind of, 300? So not exactly half, but, significantly smaller for AC. That's how we build the triangle properly. As per usual, if you have any questions, just leave them down below in the comment section. If this video was helpful, consider giving it a thumbs up, giving it a like, and we'll talk soon.